So far, all we've been talking about is virtual switches, otherwise known as standard virtual switches. Now we're going to focus our attention a little bit on vNetwork Distributed Switch, which is a new feature that was introduced with vSphere 4. Now, what vNetwork Distributed Switch does is it takes the best of the standard switches and centralizes it. The problem with the standard switch is that it's isolated, or that it's limited to the ESX host that you're working on. So if you have 10 ESX hosts in your cluster, now you got to take all the configurations you've done on the first one and replicate those changes across the other 9 that you have in order for you to get a standard networking configuration, so that features like vMotion can work properly, because they'll need the same type of switch on all the other hosts, so that this virtual machine can migrate between all of them. It also needs all the other port groups and switches that are available on the original host in order for it to communicate on the same VLAN and make sure it has access to the same network and subnet that when it moves from ESX host to ESX host. So this can be very cumbersome, especially if you have large clusters. Now, the whole idea of virtualization is that we want to make things easier, and as we move towards virtualization in a complete fashion, we want to have the ability to have centralized management. We don't want to have to go from each ESX host to make these configuration changes individually. So what vNetwork Distributed Switch gives us, or brings to the table, is a centralized virtual switch that can span multiple ESX hosts. So instead of making a change on each ESX host, you now make it on a centralized virtual switch, and any host, any ESX host that is subscribed to this virtual switch gets access to the same port groups, same subnets, same networks, etc., etc., so that you don't have to make these multiple changes. You can see how this can reduce configuration and change time, because again, you're not having to do this multiple times. This also reduces the window of error because you're doing it once. Now, a vNetwork Distributed Switch, otherwise officially abbreviated by VMware as a VDS, has what's known as a DV port. Now, DV port groups are the equivalent of port groups in a standard virtual switch. In order for you to distinguish them, they're called DV port or DV port groups. The switch in a VDS environment would be called a DV switch. Now, moving on to some additional features that you get with the VDS, you get the ability to do private VLANs. Now, what is a private VLAN? Why do I need it? What is it exactly? So a private VLAN is a way for you to subdivide a VLAN. So today you have a VLAN, all the hosts can be part of that VLAN, but if you wanted to further isolate further groups of hosts, you can do sub-VLANs. Now, sub-VLANs are easier to configure, so if you needed to have hosts in isolation or hosts in community, etc., etc., you can do that with the use of a private VLAN. Now, the way you create a private VLAN is you're going to take an existing VLAN the way it is. That's otherwise known as the primary VLAN. It's the original VLAN. Now, that original VLAN can have multiple secondary VLANs. What happens with secondary VLANs is you're going to get a VLAN ID that you get from the primary VLAN, and then you're going to get a subset of that VLAN ID. So every packet that goes in and out of the secondary private VLAN gets an additional ID tagged to it so that you can identify it, so that the switch that's connected to, the physical switch that it's connected to, can understand that the packet that is coming has a VLAN ID of, let's say, the original VLAN was VLAN 1. The secondary private VLAN is 12. So the packet would look like 1.12. And I'm going to show you when we go into the GUI configuration, this will be a little clearer, so it's a little confusing here, how you can append that ID to the original VLAN ID so that the physical switch that the packet is communicating with can understand where this is destined to. Now, you can have multiple secondary private VLANs, and they have 3 modes: either promiscuous, isolated, or community. And we're going to talk about this in the next slide here, but I just want to give you a general overview. I know this might not be very clear right now, but I'm going to show you a figure that further clears up this, but it's going to become very clear once we go into the GUI, because I'll be able to show you how you can tag this ID. So let's move on to defining what the promiscuous, the isolated, and the community mode for a secondary private VLAN can do. Now, a promiscuous port is typically associated with a router. A promiscuous port can talk to any other port group or any other mode. So it can talk to the isolated and it can talk to community. Now, what isolated is exactly what the name implies. You put a host in an isolate secondary private VLAN, and the only port it can talk to is that promiscuous or that router node or port. Now, a community means that you can have 2, 3, 4 multiple hosts in that community that can talk to each other and also can talk to the promiscuous port. Now, the community can also send packets to any other secondary private VLAN, any other community secondary private VLAN. So if there's multiple secondary private VLANs that are community, then they can talk to each other, and obviously they can talk to hosts that are part of their community and with the promiscuous port. Now let me show you an illustration of what a private VLAN can look like. Again, this is going to be very clear once we log into the GUI and we start doing some configuration. But the idea here is you see the main VLAN, and then you see the secondary private VLANs. So we have 5 secondary private VLANs. You have 2 that are community, tagged in green. So they can talk to each other, and the hosts that are within these communities can obviously talk to each other. And then you have the red, which is isolated. It only has one host, can talk to the promiscuous, which is the router, but that's the only thing it can talk to. And you can see that those are isolated. And then you'll see in blue you have the promiscuous, and I put a router in there just to illustrate that most often it's a router. Now you obviously can also have hosts in the VLAN that are not part of any secondary private VLANs. They're just hosts that are added to a VLAN. So all of those can talk to the switch, etc., etc. Now moving on to networking policies. Now I'm not going to go into all the networking policies because we covered those in the standard virtual switch discussion. So they're typically the same. There's only a couple that are new to VDS, which are VLAN and port blocking. So with VDS you can now do port blocking, and it is exactly what the name implies. It allows you to block communication with certain ports, etc., etc. VLAN is the ability to have virtual networks join physical VLANs. Now if we move on to VM Direct Path. VM Direct Path is a feature, again, that was introduced with vSphere 4. The advantage of having VM Direct Path is that it allows you to take a PCI device and attach it directly to a VM. Now, why would you do that? Well, the reason you would do that is prior to VM Direct Path, there was a lot of complaints that certain applications could not be virtualized because you couldn't give them enough horsepower. You couldn't give them enough I/O to be able to support what this application needs. Well, with VM Direct Path, now you can take a PCI device, a physical PCI device, and dedicate that PCI device to that VM. So there's no translation going through the kernel. You're talking directly to that PCI device. You're getting all the I/O traffic that you need, whether that's a storage or networking. So at this point, there's no reasons anymore to say that there are certain applications that you can't virtualize because of I/O limitations. With VM Direct Path, that takes care of it. Now, as you notice here, that there are certain limitations. If you're using VM Direct Path, you can't do vMotion, you can't do hot add, you can't do a suspend and resume, etc., etc. And there are reasons for that. Now, this is generation 1. Obviously, with the next iterations or generations of VM Direct Path, I'm sure they'll find ways to get around some of these limitations. But today, you can't vMotion or do hot adds on certain virtual machines that have the VM Direct Path. Now, some of the questions that are obviously going to come up is, well, why would I want to do that with a virtual machine if I can't take advantage of all these resources? Well, the answer is simple. Hardware is always going to be more advanced than software. So in the past, even if you get a 1-to-1 or a 2-for-1 ratio when you're virtualizing, so you take two physical machines and put them on one physical host, so you virtualize basically 2 physical machines, that's still good, because I'll give you an example. Exchange 2007. I believe Exchange 2007 has a CPU limitation of 8 cores, I believe. Well, you can buy servers today that come with more than 8 cores in them. Now, if you take this, for example, a DL or an HP DL 580, that typically can come with more than 8 cores in it. Now, if you take this whole box and dedicate it to Exchange 2007, okay, it's going to run great on it. But the application can't take advantage of all the hardware. So it's useless at this point. So instead of doing that, if you take this DL 580 and put ESX on it and then virtualize 2 instances of Exchange, then you're taking advantage of the hardware at least, because now both instances are taking full advantage of all the hardware that's available on the server. So even though it's a 2-for-1 at this point, the ratio is not great, it's still better than putting Exchange on hardware that is being underutilized at this point because the application can't take advantage of it. Now obviously for VM Direct Path to work, you're going to need certain CPU models, especially in this case we're talking about the Intel Nalem processor. Now, but I would also suggest, depending on when you're viewing this CBT, VMware could have added more support for other processors. And if you're taking the VCP exam, I'm going to strongly recommend that you research this particular area because the requirements change frequently, and I just want to make sure that you guys are always up to date with this stuff. So double check with the HCL, the hardware compatibility list at VMware before you take the test, especially because they could be adding support for more processors, most especially AMD. At some point, I'm sure AMD will also be supported. Now, as of today, as of Generation 1, only 2 PCI devices can be attached directly into a single VM. So a maximum of 2 only. So NetQ. NetQ is another advanced networking concept. So the idea with NetQ is that you can leverage the capability of certain network interface cards that can receive multiple streams. They have multiple receive queues, as we call them, that you can receive on. So instead of having just this one that you're receiving and processing, now you have multiple streams that you're receiving on, multiple queues that you're receiving on and processing separately. That obviously will improve performance. It gives you the ability to schedule the processing of these receives queues on multiple CPUs, which in turn was going to enhance performance greatly. Jumbo frames. Well, who doesn't want to do jumbo frames? So with ESX, it allows you to send larger frames onto the physical network. Now, obviously, you're going to need the physical switch that you're connected to support jumbo frames before you can do that. So you need an end-to-end support to jumbo frames, basically, before this can succeed. Now, the maximum frame size that you can do here is 9 KB or 900 bytes. Now, in order to enable jumbo frames, you have to do that through a command line, and we'll do that through the process of the demonstration. I just wanted to lay some groundwork here. Alright, let's talk about the Cisco Nexus 1000V. Now, this has been so heavily advertised, and everyone's made such a big deal out of it because it's the first third-party virtual switch that you can install and use and configure from within vSphere. So with the introduction of vSphere 4, you can now have third-party virtual switches that can plug in and take advantage of the VDS APIs and replace the VDS or the vNetwork distributed switch and act as the centralized virtual switch for your vSphere environment. Cisco is the first company, the first third-party company that has developed a virtual switch that can plug into the VDS API and take advantage of it and replace it. Now, some of the advantages that you get with the Cisco Nexus 1000V is for your network administrators or for your networking team in general. They now have visibility into the virtual environments. Prior to vSphere, the network team's job stopped at the uplinks to the physical switches. They couldn't see what was happening inside of the virtual environments. With the release of vSphere and Cisco Nexus 1000V in particular, now the networking team has more visibility into the virtual environment because their reach now extends into the networking piece. They're now taking back the networking piece in a virtual environment. And that's a good thing, because as virtualization becomes mainstream, you want to try to mimic what you're doing in virtualization with what we were doing in the physical world. In the physical world, the networking team took care of networking. So in the virtual world, the same thing has to transfer. It has to move over. As virtualization progresses, as more features are added, you don't want to have to deal with all the networking concepts. And you'll notice through this presentation that there's a lot of networking concepts that I'm going through that typically a server admin wouldn't even want to touch or know about. But we're going to cover them. But this demonstration is geared more towards the networking team, towards what they can do with the Nexus 1000V, how to install it, who installs what, and where the limitations and the obligations stop. Where the server admins, what they have to do, what's their tasks, and where does the networking team come in and where are the borders. We need to define some limitation so that each team knows where to stop and where to start in a virtual environment, and I'm going to try to illustrate that during the course of this presentation. So some of the features, some of the benefits that you get with the Cisco Nexus 1000V is policy-based VM connectivity. You get mobile VM security and network properties. You get non-disruptive operational models. The Cisco Nexus 1000V also has two components. You have the virtual Ethernet module, and we're going to talk about that in a second, and you have the virtual supervisor module. Now, for your networking team, they're probably very familiar with supervisor modules because that exists in most of the other Cisco products. Now, the Cisco Nexus 1000V is also based off of an XOS instance, so they're familiar with the OS that comes with the Nexus 1000V. All the commands are there, most of the commands are there, so it's not like they're coming into unknown territory. This is familiar grounds for the networking team. So if we move on to the virtual Ethernet module a little bit, what the virtual Ethernet module represents is it's going to replace the standard virtual switches on every ESX host. So what happens is once you start using the Cisco Nexus 1000V, the VEM is going to replace the virtual standard switch on every ESX host. You make all your configuration on the VSM or the virtual supervisor module, and that in turn will automatically replicate all the changes to all the VEMs on every one of the hosts. Now, some of the advantages that you get with using a VEM is you're going to get quality of service, or QoS, you're going to get private VLANs, you're going to get access control lists, and you're going to get NetFlow and span. Now, those are all features, they're all networking features that the networking team should be familiar with. We're now bringing these features to the virtual environments. So now let's move on and talk about the virtual supervisor module. Now again, the VSM is a Cisco NX, like I told you, it's a Cisco NX OS instance running inside of a VM, and we're going to install that, and I'm going to show you where the network administrator's job begins and where the server administrator's job begins with the installation and configuration of the Cisco or the virtual supervisor module. It controls multiple VMs, like I mentioned, and configuration is performed at the VSM level and propagated to all the VEMs. Alright, this concludes the lecture part of our presentation. What we're going to do now is we're going to log into the GUI. We're going to start taking a look at some of these features that we've been talking about and see how we can configure them and install them and get them to work. So let's get started. Alright, so we've logged into Virtual Center. Now the first thing we're going to do is we need to create a new vNetwork distributed switch, or a VDS. Now, before I continue, there's one thing that you guys should note, and especially note this for the VCP exam. In order for you to get a VDS, you need an Enterprise Plus license of vSphere. So that's the only license that allows you to get a VDS. Now, this is the same thing for the Cisco Nexus 1000V. You'll need an Enterprise Plus before you can get access to the Cisco Nexus 1000V. Now, assuming you have a license, what we're going to do is we're going to go through the steps of creating a virtual or a vNetwork distributed switch. Now, the first thing we want to do is off of the home screen, we want to go to networking. Now, the first thing we're going to do is we're going to right click on your data center. In my case, it's Chicago. So we're going to right click on it. We're going to scroll down to new vNetwork distributed switch. You're going to have to give it a default name. In my case, I'm just going to leave it a DV switch. And you're going to choose the number of uplinks you want to allow this switch to have. You can change the number here. I'm going to leave it at default for now, or actually let's increase it to 8. And as we move on with the GUI, we're going to add hosts and we're going to add those uplinks. So I'm going to leave it at 8 and we're going to click on next. Now it lists the host that I have in this virtual center instance. You can choose to add a host later by selecting the second option, or you can choose to add a host now. In my case, we're just going to go ahead and add this host right now, and you'll notice right away that it's going to list all the NICs that are associated with this host that allows you to choose your uplinks. So I'm going to go ahead and select all the uplinks that I have here, and we're going to click on next. In this screen, it's going to allow you to create a default port group, so I'm going to leave that as well, and I'm going to click on next to continue or to finish. And that's all there is to it. You just created your first VDS or vNetwork distributed switch. It's very simple. Now you're going to notice as we go through the exercise, how to add virtual machines, how to remove virtual machines, and we're going to play a little bit with the policies. But we just created the first virtual switch pretty much, or VDS. So you can expand on it here. This is your first port group. Now, before we move on, let me show you something real quick. If you wanted to remove a host from a VDS, it's very simple. You click on the switch here, and you're going to move over to host. You're going to right-click on this host, and you're going to scroll down to remove from distributed virtual switch. It's very simple, very straightforward. For the purposes of this example, we're just going to leave it now since we want to work with it. Alright, now as with standard virtual switches, nothing can be accomplished without port groups. Port groups are what provide connectivity to the virtual switch. So you need to configure the appropriate port groups, whether it's service console, vkernel, or just virtual machines, and the VLAN IDs. The same concept, the same exercises that we did with the virtual standard switches, we're going to have to do here to illustrate the power of port groups again and their necessity. So we have a default port group that we can modify, but for the purposes of example here, we're going to go ahead and create a new one. So we're going to right click on our virtual switch, and we're going to scroll down to new port group. Now you'll need to give this port group a name that makes sense. So in my case, I'm just going to say, I'm going to leave it DV, and I'm going to name it servers. And we're going to call this VLAN 32. Now, it gives you the option of selecting how many ports you want. I'm going to leave it at default 128. You can feel free to increase or decrease this. Now, the VLAN type, you need to tell the port group what type of VLAN this is. Now, if you keep it at none, then it's going to accept traffic from untagged packets. If you select from the drop-down menu VLAN, now you have to specify the VLAN ID. Now, in my case, it might match what I put in the description, so it might be 32. So it's going to accept packets from VLAN 32. Now, the other options in the drop-down menu here are VLAN trunking. If you select VLAN trunking, then you have to select a range of VLANs that you want to accept traffic from or packets from. Now we're going to talk about private VLANs in more detail in a little bit, but here's where you would configure it at the port group level. Now obviously it's going to give us an error because we haven't configured private VLANs at the switch level yet. So we would configure private VLANs at the switch level, and then we would come back into the port group and specify it here. We're going to go through that exercise. For this example, I'm just going to keep it at none, and we're going to click on next to move forward. It's very simple. Click on finish. Any virtual machine that you add to VLAN 32 will get access, physical or connectivity access through this VLAN. Alright, now let's go through the exercise of adding a virtual machine to this new port group that we created. So what I'm going to do is I'm going to click on inventory here, and we're going to scroll down to VMs and templates. I'm going to take Shy VM FS01, we're going to right click on it, or you can simply click on it and go to its summary tab here and scroll down to edit settings. And it's the same method by which you would change the VLAN on a standard virtual switch that you do here with the distributed virtual switch. So you go to network adapters for that particular VLAN or for VM, and from the drop down here we are now going to select VLAN 32, which we just created. And you'll notice it's on a DV switch. Now you can do advanced port settings for this if you wanted to by selecting it and going through adding a virtual switch here and going through the advanced. We're gonna go through this again later on. I just wanted to show you what you could do through this screen. So for now we're just gonna select the network label, and we're gonna leave it at VLAN 32. We're gonna click on OK, and we're gonna go back to the networking portion and see the changes that happened on the port group itself. So we're gonna select this port group here, and we're gonna go to ports, and you're gonna notice that Shy VM is now connected on port 137 to this port group in particular. You'll notice that it's VLAN access here because we haven't done anything. There's no port blocking, etc., etc. Alright, now watch this. You'll notice that the VLAN ID here is 0. So if I wanted to match the VLAN ID, which in my case I selected 32, and make sure it connects the VLAN ID 32, we're going to right click on that port group again, and we're going to go to its settings. In the VLAN section here, we're going to change it from none to VLAN, and I'm going to give it VLAN 32. Click on OK, and And all I have to do here is pretty much refresh the screen, and voila, there you go. Pretty slick, huh? Now with regards to the rest of the tabs that you see here, they're pretty much the same tabs that we've been talking about and we've been drilling through all through the CBT, so I'm not going to go through all of them, but I mean they're pretty much self-explanatory. The ports tab here is going to list all the tabs and which VM is connected to which port. You'll be able to get statistics on it. You'll be able to start monitoring the port state, and you can start and stop that actually. You'll also be able to click on the virtual machines, and it's going to list all the virtual machines that are configured on this with this port group, the hosts that are participating, tasks and events, alarms, and permissions, obviously. Alright, let's go back into the settings of the port group here and make sure we cover all the different functions or the settings. So the general tab is pretty much self-explanatory. It gives you the name, description, number of ports. We went through this during the setup of the port group. Alright, so the port binding here, the default is static binding. This is when it's initially connected. The dynamic binding that you see here is when there's a connection or when it's powered on, and then you have the ephemeral is when there's no binding. So we're going to just keep it at the static binding here. And we're going to move over to the second feature here, which is policies. Now we've talked about policies again throughout the video when we were talking about vStandard network switches. So this is the same. I just want to go through some of the differences that you see in this screen or on this screen. Okay, so the security is the same as we've been discussing, so I'm not going to go over that. Now you're going to notice ingress traffic shaping. Now ingress traffic shaping gives you the ability, gives you the flexibility of doing traffic shaping between the VNIC and the virtual switch or the V switch. So by default it's disabled, but you can enable it and then tweak all the settings, peak bandwidth, average bandwidth, etc. We're going to leave it at disabled, and we're going to move on to egress. Now egress traffic shaping is the exact opposite. It's the ability to do traffic shaping from the V switch to the VNIC. Again, the same types of configuration that you have. Now you'll have the ability here to also make changes on the VLAN itself, and we talked about those. We actually have made the VLAN ID, as you can see here. The teaming and failover features are the same, so I'm not going to go over those. You'll be able to take a look at the uplinks as well, and be able to set priorities or move them up or down by moving using these buttons up or down. Then this is just standard. We've talked about this. It's the same thing as with the virtual standard switches. Alright, during the presentation we also talked about port blocking, so I want to show you where that can happen. If you click on miscellaneous here, you'll see that you're able to block all ports. Now we'll talk about port blocking on an individual basis a little later on. But if you wanted to do a block all ports, which means you are going to drop the traffic on all of the virtual machines that are connected to this DV port group, you can switch this setting here from no to yes. But be careful, if you select yes and click on OK, you are going to drop all the connections with all the virtual machines that are connected on this port group. So use caution before you actually select this option here. Alright, let's move on to the advanced option here. You'll notice that you have override port policies. Now with override port policies, what you could do, if you have that selected, then you'll be able to also click on edit override settings and select individual features that you want to allow override on or not. So you might want to be able to allow overrides on block port or traffic shaping or vendor configuration, etc., etc. So this is where you would set that up to allow override of port policies. So instead of having a port group wide policies here, you can come in and override it and make it a little more customizable, so you can go down to the port level and make some changes or allow some overrides. Now the second option here is live port moving or live port migration. If you select that, then you allow a port to move from port group A, for example, to port group B. You retain all of its settings. That might be a useful feature. The only thing I want to warn here is that if you enable this, you can't really make any configuration. It's kind of a useless setting. Most of the configuration changes that you would do for a live port moving would have to be done via command line interface. So I'm not really sure what the point is of having a checkbox here, but just to warn you, I wouldn't suggest messing with this. It's almost not worth it. The only advantage you gain here is you're able to move a port while it's connected, while it's live, without losing connectivity. So feel free to use it if there's a need for it. And this is what it does. Now the second option that you see here is configure reset at disconnect, which means if you flag this, you're able to, once there's a disconnect at a certain port, it's going to revert back to its default settings. So it's going to lose any kind of special settings that you've done on that port, and it's going to revert back to its default settings. Now with port naming format, it's just a naming convention for your label. If you select from the drop down menu here, you're able to change the naming conventions, or you're able to make up your own. Alright, let's get out of this screen and go and take a look at how we can manage uplinks, or how we can manage the network adapters. Now you can click on the home screen here and go to, we want to get to hosts and clusters, or you can use a hotkey. If you're into hotkeys, you can hold down Control Shift and H, and that's going to take you directly, voila, it's going to take you directly to the hosts and clusters. It's just a shortcut. So if we select our ESX host here, go to configuration, and that's obviously selected. We're going to go to networking. Now here you'll notice that you have the option of taking a look at your standard virtual switches, or you could take a look at the distributed virtual switch. Okay, so with a standard virtual switch, it was easy to add vMotion port group, or it was easy to add a service console port group, or a VM kernel port group for that matter. You just click on add networking, ba bing, ba bung, it was there, it was an option, you would select it. Now with a VDS, or a vNetwork distributed switch, it's a little different. So we're at the networking tab here, and what we're going to do is here you have two options. You can manage virtual adapters, or you can manage physical adapters. Now physical adapters are your standard physical uplinks. They're just a physical NIC that you add to the server and you can assign here. So you can click on manage physical adapters here, and you can go through each and every one of them. But that's not what we want to do here. This is a pretty basic, straightforward configuration. The manage virtual adapters is what you would select in order for you to create what we used to create with a standard virtual switch, as far as a service console or a VM kernel. So what you would want to do here is, if you wanted to create a service console, you could select that. For the purposes of this example, we're going to go with a VM kernel. And in order to add, what you're going to have to do is you're going to click on this add button. Now, two options. You can create a new virtual adapter, and then you can associate that with either IP storage if you're doing iSCSI, blah blah blah, or you can associate that with vMotion or fault tolerance, and we're going to take a look at it. Or the second option would be to migrate existing virtual adapters. Now, what migrate existing virtual adapters helps you to do is to take a port, or a port group that's on a virtual switch, on a standard virtual switch, and migrate it to VDS. So if I click on migrate existing virtual adapters here and click on next, you're going to notice that I have the service console, and you'll see that the service console is part of vSwitch 0, which is on an ESX host. If I continue with this migration, then I'm going to move over the service console from the ESX host's virtual standard switch to VDS. Now again, we're not going to go through that just yet. I'm going to select new virtual adapter here. We're going to click on next. Now it's going to give you the option. Do you want VM kernel? Do you want service console? We're going to click on VM kernel again. Now we're going to select the virtual, or the port group that we want to associate this with. So we've created a port group before. I'm going to use the standard port group here. I'm going to select that. Now you can select a standalone port group if you want. Now if you wanted to use this for vMotion, all you would have to do is select this checkbox. If you're doing fault tolerance, you would select the second option. For the purposes of this example, we're going to use this for vMotion. You can feel free to specify the IP address, the subnet mask, and the default gateway. Again, just for the purposes of this example, I'm going to go with the default. And there you go. You get a summary screen of what you're about to do. We're going to click on finish here. You're obviously going to be prompted to select a default gateway. We don't want to set a default gateway at this point, so we're going to click on no. And voila, bada bing, bada boom, it's easy. We just added a new VM kernel virtual NIC. Now if you click on close, you'll notice that we have a VM kernel port here, that VMK0, that we're using for vMotion. So in the event that you wanted to add a service console, you would do the same thing, so on and so forth. Alright, now what we're going to do is we're going to take a port group that exists on a standard virtual switch, and we're going to migrate it to VDS. So let's take a look at the standard virtual switches here. I'm going to take this port group, which is a VM kernel port group, and we're going to migrate this to the distributed virtual switch. So we're going to click on Manage Virtual Adapters here. Now again, you're going to notice that only Service Console and VM kernel is what I can do this with. So I'm going to click on Add. We're going to do Migrate Existing Virtual Adapters. I'm going to uncheck the Service Console. I'm going to select the VM kernel here. Now I have the initial where I'm moving it from, but I need to also select the destination, so where I want to move it to. So I'm going to select the drop-down menu here, and I'm going to select DV port group. Next, it's going to give me a summary, and I'm going to click on Finish to execute. Now you'll also notice that it is going to add this in just a second here, and there it is. We now have VMK1, which has been moved. Now if we go back to the virtual switch view here, you'll notice that it stripped it out of the VM kernel association that we had created the virtual switch with, or the virtual port group with. So now you have a virtual switch that has no port groups configured on it, because the VM kernel port group that was configured on this virtual switch has been migrated and is now VMK1 on the VDS. Okay, now let's talk a little bit about private VLANs. We said we would come back through the GUI and show you how you would create a VLAN and how you would configure it, and why this would be clearer using the GUI. Now at this point we are on the hosts and clusters, and we're looking at the configuration and the networking tab. If I wanted to jump to the networking tab, or jump to the networking page in general, there's two ways of doing this. You can obviously go through the inventory here and click on networking, or you can do Control Shift and N, which I find a little useful, and voila, you jump back to here. Now the first thing you want to do when creating or configuring private VLANs is, first we want to configure the private VLANs on the virtual switch, on the DV virtual switch in this case. So what we're going to do is we're going to right click it, and we're going to drag down here to Edit Settings, and we're going to click on Private VLAN. Now obviously you can take a look at the network adapters, etc., etc. You have the properties of the DV switch, but for the purposes of this example we're going to focus a little bit on private VLAN. So the first thing you want to do is you want to give the primary VLAN an ID. So what's the VLAN ID? We're going to select, for the purposes of our example, let's do 100. And voila. We have now the primary private VLAN ID is 100. Now what we need to do is give this primary private VLAN ID the sub ID, the ID that's going to identify which is the promiscuous ports, which are the isolated ports, and which are the community ports. Now you'll notice by default it gave the secondary private VLAN type promiscuous is 100. Now let's say we enter 102, and we can select here isolated, for example, and I'm going to do 103 and select community. So you'll notice here that now when it wants to tag the ID, it's going to have to take advantage of the 102 and 103 IDs that I specified here in order to identify if this is an isolated port, or if this is a community port, or if this is a promiscuous port. So this is the initial setup that you have to do on the DV switch side. This is on the switch side. Now we're going to go into the actual port groups and we're going to configure this a little further, but I wanted to show you where you can actually configure this. Now you can obviously remove it. It has the range of what you can and cannot do. So I'm going to click on OK here to make sure it takes effect. Okay, now you can either create a new DV port group that takes advantage of these new private VLAN configurations that we did, or you can take an existing DV port group and configure it for that matter. So we're going to take the default DV port group here, and we're going to click on Edit Settings. We're going to click on VLAN, and now we're going to select Private VLAN. Now notice before when I was showing you this, when we clicked on Private VLANs, it gave you an error because there were no private VLANs that you can select from. But now that we've configured it on the virtual switch level, now it gives you the option of configuring the port group. So what kind of private VLAN, what kind of an entry is this? You can select promiscuous, which is 100, and you'll notice the tag next to it. Or you can select, again, isolated, and you'll notice its ID, its sub ID. So we gave it a VLAN ID of 100, but the sub VLAN ID is 102. So that packet is now going to have 100, 102, so that when the physical switch receives this, it knows what type of a port this is. So I'm going to select community here, and I'm going to click on OK. So what I just did for this is I took the ports, all the ports of this port group, and I made them community port groups. Now, how do I see that? We've selected the port group, so you can click on ports here, and you'll notice that if you do a quick refresh here, just hit F5, you'll notice that the VLAN ID is now a community, and you'll see the VLAN ID with the sub VLAN ID also attached to it. So it's 100, 103, and that's the 103 that identifies this as a community port. Okay, now what if you wanted to take certain ports on this port group and make them part of isolated or promiscuous? You don't want them all to be community. Well, that's easy. You can right click on individual ports, click on settings, and then you go to VLAN. Oh, it's grayed out. Can anyone tell me why this is grayed out? Actually, let's go through some other settings. Oh, policies is grayed out too, so technically I can't do anything on this port. Now, why is that? Anyone? Bueller. Okay, so if anyone said that we didn't specify the overrides on the port group, you're absolutely correct. So in order to enable some of this functionality, what you have to do is come back up here to the port group. We're going to go to its settings, and remember when we were talking about advanced, this is where you would allow override of certain policies or certain port group policies. If you uncheck all of it, then you can override all of them. But if you keep this selected and you edit the override, now you can become a little granular with what you can and cannot edit. So for the purposes of this example, what we're going to do is we're going to allow it to override VLAN, for example, and we're going to allow it to override block port and traffic shaping. We're going to click on OK. And we're going to try this again with the port group or with an actual port. So I'm going to right click on this port. We're going to go edit settings. We're going to click on traffic shaping. And voila, look at that. Now I have the ability of overriding the overall port group settings by digging down to the actual port and selecting whatever I want here on a port by port basis. Now I'm going to leave this disabled. Now you can come here to VLAN, which is kind of relevant, but this might come in hand. And instead of having it as community, I now want this port to be an isolated port. I'm going to click on OK. Now you'll notice it changed. It took effect even without me having to refresh it. It was moved from a community port to an isolated port. Some pretty cool stuff that you could do with the distributed virtual switch now, can't you? I mean, this just makes life so much easier. Now, in all fairness, and this is, again, I'm recording this, we're still in December of 09, so today not a lot of people are using the virtual distributed switch. People are still using the standalone virtual switches still. But as virtualization starts to progress, as these options start to make more sense and people start to realize how much easier their lives are going to be by using this, by not having to configure 20 or 30 standard virtual switches every time you add a new ESX host, and that you can do this centrally from Virtual Center via a distributed switch, people are going to slowly start migrating towards that, and as people become a little more knowledgeable of the features and functionality of the distributed switch. Now I hope you found this enjoyable and knowledgeable. The next thing we're going to start talking about here is the Cisco Nexus 1000V. That's a really cool topic. Stay tuned. Okay, so let's go through the installation of the Cisco Nexus 1000V. So what I'm going to do in this video is I'm going to try to divide it into two parts. The first part is going to cover what the server admin role in the Cisco Nexus 1000V installation is, and the second part is going to be what the network administrator role is going to be in the Cisco Nexus 1000V setup and configuration. This should provide a clear line that you can use in your environment to define where your roles begin and end, and where the network admin's roles begin and end. Now, for you to download the Nexus 1000V, you want to go to cisco.com/go/Nexus1000V. You can download a 60-day evaluation copy if you want to try it out. Now, just so you know, in order for you to use the Nexus 1000V, you need to have the Enterprise Plus, the VMware vSphere Enterprise Plus license, in order to use that. Now, can anyone tell me why we need the Enterprise Plus? It's not just because, oh, VMware wants to make more money. There's actually a reason behind it. Well, they do want to make more money, but there's a reason behind it. So with the Enterprise Plus, you get VDS, vNetwork Distributed Switch. Now, the Cisco Nexus 1000V is simply a third-party virtual vNetwork Distributed Switch, which means it's going to plug into the VDS APIs, replace it, in order to provide the functionality of a global or a centralized switch for your cluster. So the first thing we're going to do, obviously, is we're going to download the Nexus 1000V, and that's going to be in the form of an OVA. Now, the first part of this demonstration is going to involve the server admin's role in this. So after you've downloaded this, what we're going to do is we're going to go up here, click on File, and we're going to deploy OVF template. And mine is pre-selected, so I'm going to click on Next. Now, as of version 4.0.4 SV12, the Nexus 1000V now has a GUI install. So you no longer have to go through a manual process. For the purposes of this demonstration, we are going to show you the GUI install portion rather than the manual install, which is something new again as of 4.0.4 SV12. So we're going to click on Next to continue here. We're going to accept the license agreement. You guys can feel free to read the whole thing. And I'm going to name mine just Nexus 1000V. We're going to click on Next. Now this is where you can select either the GUI installation or the manual installation. Again, for the purposes of this demonstration, we're just going to stick with the GUI install. We're going to select the host. Now, had I had more than one host, physical ESX host, they would show up in this list. What you want to do here is you want to select the physical ESX host where you chose to deploy the OVA file. In my case, it was this server. We're going to leave this at default. I'm going to select the default storage. Now it's asking us to give it a password, so we're going to do Cisco 123. I'm going to give it an IP address of 10.12.112.191, subnet mask, and a default gateway. I'm going to click on Next. You can feel free to go through the summary page, make sure everything's okay. When you're ready, we're going to click on Finish. Now it's going to take between a few seconds to a few minutes depending on your network speed, the speed of the server, etc. Wow, actually mine has gone kind of quick. We're going to click on Close here since it's completed. Now you can go to the hosts and clusters if you choose. I'm going to go click on Control-Shift-H, and voila, I love those shortcut keys. Now you'll notice that your VM is here. We're going to power it on, and once this VM is powered on, this would end, or this would complete all the steps and tasks that the server admin would need to complete for the purposes of setting up the Nexus 1000V. At this point, the network admin would jump in and finish off the installation. Now, as far as the network admin is concerned, there's going to be a couple of more steps before he can telnet and use some of the tools that he or she is used to. So the first thing we're going to do here is we're going to open a web page, and we're going to browse to the IP address that we configured, which is 10.12.112.191. And this would bring us to the virtual switch web page. What we're going to do here is we're going to launch the application, the GUI install application. Now you'll need Java to be running on the host machine that you're running this from, because this is a Java-based application. We're going to run it. And there it is. Now the first thing that it's prompting us to do is to enter the VSM password that we configured. Hopefully the server admin will pass you this password and won't give you a hard time. Click on Next. Now we're going to give it the virtual center IP address and also an administrator or a user account with admin rights on that virtual center server. This is going to be used to enumerate all the hosts and virtual machines in Virtual Center, as you're going to see here in a second. And there it is. Now again, it would list all the hosts that you have. I'm going to select the host that my VSM is configured on, which is 151. We're going to click on Next. Now, here it's going to enumerate all the virtual machines that are available on this host. Now I have more than one. What you want to do is from the drop-down menu, we want to select the Nexus 1000V. Once you've chosen that, now you can either go with the default options, default configuration, or you can click on Advanced for more granularity. It gives you the option of choosing the different VLANs for control port, for management port, for packet port, etc., etc. It gives you more control over what you want. Network admin should be able to handle the screen. For this, for the purpose of this example, we're just going to go with the defaults. We're going to click on Next. Now we need to name our switch. So I'm just going to name it 1000V. We need to select a password. And this password needs to have uppercase, lowercase, and a number. I'm not telling you what mine is. We're going to give it an IP address. Again, we're going to have to do a subnet. Default gateway. Domain ID, we're just going to give 50. I'm going to keep the data center as Chicago, and I'm going to enable Telnet. Now, enabling Telnet allows the network administrator to do an SSH connection with tools like PuTTY, which they're used to doing in the physical world. So now they can do a PuTTY or a Telnet session into the virtual switch as well. That would allow them to issue some of the commands that they're used to issuing with the Nexus OS or the iOS operating system. We're going to click on Next. Now you can feel free to go through the summary page here, make sure everything's okay. Once you're comfortable with what you see, we're going to click on Finish. And the installation is going to go through. Configure everything, and this might take a few minutes here, and voila, it has completed successfully. We're going to click on Close here, and we're going to go back into Virtual Center. Again, you can go to Inventory Networking if you choose. I'm just going to do Control Shift, and I'm going to click on N, and there you go. There's our switch, etc., etc. Now at this point, the network admin can SSH into the switch, telnet into the switch using PuTTY or whatever. He's got a familiar interface. He's got a familiar operating system, NX-OS. It's kind of a version of iOS, if I may say so. So he should be familiar with the commands, and this should be managed the same way you would manage a physical switch. You can create port groups, etc., etc. I hope this video has been helpful, and I'd like to thank you for viewing.